Question number 81. Which of the following contains equal number of sigma and pi bonds? If we talk about the given species, first is CaCN2, carbonate ion, NO3 negative, nitrate ion, and NO positive ion. There are 4 species which are given. We have to just check whether these are containing equal number of sigma and pi bonds or not. So first we have this ionic compound CaCN2. It is basically consists of one ionic bond between calcium and Cn. So it can also be written as Ca2 plus and Cn2 negative. Now we have this ion. We have to check in this ion how many sigma and pi bonds are present. So this ion can be represented as carbon joined with 2 nitrogen atoms in this way, and both of these nitrogen atoms have negative charge. If you look at the structure, you will identify that there is sigma bond between carbon and nitrogen this side and this side also, and there are 2 pi bonds also. So by looking at the species, you will identify that there are 2 sigma bonds as well as 2 pi bonds. Equal number of sigma and pi bonds are present here, but in case of carbonate ion, you will identify by checking its structure that equal number of sigma and pi bonds are not present. 1 pi bond is there, other sigma bonds are present. Now if we talk about NO3 negative ion, so this is also of this type. This is NO3 negative ion, and in this case also sigma and pi bonds are not equal. While if we talk about this nitronium ion, in this case bond order is 3 and the same number of pi bond and sigma bonds are not present. If you look at the structure, 1 sigma and 2 pi bonds are present. That's why the only equal number of sigma and pi bonds are present in case of CaCN2, and I will choose it as my correct answer. Now let's take question number 82. Correct order of ionic character is, we have hydrides of different elements: calcium hydride, barium hydride, and hydride of carbon, that is methane is given. Similarly in all these options it is same, but we have to arrange these 3 compounds on the basis of increasing ionic character. So if we talk about methane, that is CH4, and it is a covalent compound. This bond is formed by sharing of electron, so all the bonds are covalent bond, so it would have least ionic character. Now if we talk about calcium hydride and barium hydride, in these 2 cases metallic hydrides are there, but in case of barium there is more metallic character as compared to calcium. So if an element is there which has more metallic character, that definitely has more ionic character in its hydride. So the most ionic in this case is barium hydride. After that there is a turn for calcium hydride, and methane would be at last. So which option is correct here? If we compare this order, we will find it out that this is correctly given in option 2. And our answer is also option 2. Now after this, question number 83. Which of the following is dominating intermolecular force that must be overcome in changing acetone from liquid state to gaseous state? It means you have acetone. This is acetone. It is in liquid state and you just want to change it into the acetone in its gaseous state. Now in this case we have to identify the force. First is dipole-dipole interaction, then hydrogen bonding, London dispersion forces, and covalent bonds. In case of acetone, there is high dipole moment. It has dipole-dipole interaction, due to which there is intermolecular forces, and if you overcome those forces, you can convert liquid acetone into gaseous acetone. If we talk about hydrogen bonding, that is not present in this case. Even if you break the covalent bond, this whole molecule would not exist. It means there is no chance of conversion of liquid state to the gaseous state, because only we want to change the state. We don't want to break the bonds. That's why this 4th option is also not correct. So only first option is here, that is correctly represent your answer. That's option 1. Further, question number 84 is there. The arrangement of electron pairs around xenon in xenon tetrafluoride is octahedral, square pyramidal, trigonal bipyramidal, or the square planar. We have to identify the arrangement of electrons in XEF4. So if you look at XEF4, in case of this, there are 4 fluorine atoms which are joined in this way, and there are 2 lone pairs which are present in this way. So in this case, if you look at the structure, you will identify that these are the bond pairs which are present, there are the lone pairs which are present, and ultimately they are forming an octahedral arrangement. So what is the arrangement of electron pairs around Xe? That is octahedral arrangement. And if it is so, first option is the correct option, and I'll choose it as the correct one. Further, question number 85 is here. Assuming that z-axis as the molecular axis of a diatomic molecule, overlapping of px and py orbital results into the formation of. One thing you should note here, that we are talking about the 2 orbitals, and z is assumed to be the internuclear axis. And here we have the 2 orbitals. In 3D, one is px orbital. Suppose this is x-axis, so this is px, and if we talk about another orbital, that is py. If z is assumed to be internuclear axis, this is x-axis, we are talking about this py orbital. Here is the y-axis that is present here. Here is the y-axis that is present here. Now they're asking that assuming that z is the molecular axis of the diatomic molecule, overlapping of px and py orbital result into the formation of. There is px orbital, this is px, and this is py. Their overlapping is not possible. Why? Because these two are perpendicular to each other. They are at the different axes, they are perpendicular to each other. That is why there would not be the overlapping. And if it is so, there is not the formation of any type of molecular orbital. And on that basis, this option 4 is the correct one, that says no molecular orbital would be formed here. So this is the answer for this question, and that's why I'm choosing it. Further, let's take next question.